Hello guys! So I know you guys are waiting for how to draw the power triangle step by step. In the previous video, I only show how to draw the power triangle in the final product. I did not show where and the origin of the final product is from. So in this video, I will not show how to calculate for the complex numbers or anything else. I only want to show how to calculate, how to draw the perfect power triangle. Yeah, perfect. Okay, now let's get started by the example from the quiz, the homework as well. So now we have we all know that the total power is from S1 plus S2 plus S3, but it doesn't mean that you have to plus the apparent power together, because yeah, you will have a disaster if you just plus it together. It is how everything is plus together. The whole complex bunch is plus together, not only the S, not only the apparent power is going to be subtracted together or something like that. So I'm going to show you that the green color is the true power and the purple one is the reactive power. Why do we need different color? Because one is in the x-axis and the other one is in the y-axis. So I want to show you guys that it is the different colors to make you guys like, oh, this is the true power and this is the reactive power. So for the green one, we start from left to right, because normally true power is only plus sign, so it's going to the right. And for the capacitive, you know that is going down because it's negative. And then you have to start the arrow from where you left. You got what I mean? So the true power, the green color, has to continue from where you left. It means that no matter if the Q is going up or down, the P has to continue from where it is left. Okay? So now you have everything else that is supposed to do. Don't forget that calculating, like measure the length precisely, because you have to know like 20 is supposed to be longer than 9, something like that, in the actual paper. This one is only an example. Okay lah. Next, you have to you know that the P you can just plus together because the P is already positive, so it's like adding up together. There's no like subtracting, so it will be a long line. And for the Q, you know that when the minus and the plus meets together, you will lose something or you will gain something. In this case, you lose a lot, and you only have the leftover is only like very small piece of Q over there. See, it's the leftover Q that we have. So we plus with the remaining Q, which have this Q that we're having. So no matter what, the Q that we already cut off will go straight into the trash already. So you just draw the S apparent power straight from straight there, just straight from the corner to another corner. That's it. I will draw a actual triangle that you can see more clearer. Yes, so this is what it should supposed to look like. You don't have to shade it actually, but I just want to show that the shaded part is the true is the power triangle, the total power triangle, that is from the subtraction and the addition of all powers that we have in this exercise. So this is the total apparent power. Okay, yes. So I will show you another example to make sure how to really draw the apparent power, how to really draw the power triangle like that. So here we have another example. So this is the example for one of the exercise. I don't even remember what it is. So yeah, it is the right answer from the solution. Yeah. So in this case, it is not how the total P is supposed to like source plus line plus load. It is only source equals to line plus load. Source equal to line plus load is really easy to remember. No, not easy at all. Okay, so don't get confused, like you plus all the three sources together, you will have a disaster. So now we have as normal, the Q is going up and the Q for the load is going down. But in this case, I just want to make sure that we can approximately, you see that the power, the true power of the load is 1,700 something. Actually, it's almost already like almost 2,000. And for the second, for the line is already nearly 500. So it's like 4 times 3 or 4 fold. So you need to like draw it carefully. So you see that we cut the leftover out and we just connect the corner from where it is left. So the corner that it is left is from the P, because the total P is always the addition of all the true power. There is no subtraction in true power in case something that we haven't learned about. Okay, so that is the power triangle that we're trying to find. Yes, that's it, that's all. It's very it looks like complicated if we draw it, we try to draw it with labels and close all the lines together. But if we try to illustrate the professor like this is the true power triangle that we are trying to explain, this is the concept, so we understand the concept. As long as we understand the concept, I think it's okay to just draw it any kind of design that we want. Okay, so I have another example for you to look at, which is it has 4 power triangle, a lot lah. Okay, so now we see that, oh, this time we have Q equals to 0. What does it mean? It means that there's no Q. So you don't have to draw the Q. You just continue to draw the P from the leftover P. Easier, right? So now we have the P1 700 something, and then we have the 6,000. Actually it's supposed to be very longer, so it's like for the source number, what is source number 2, for the S2. And then we have the other one that is supposed to be shorter than the second one because it's like only 4,000 something. And then now you have the Q. The Q is so large, it is almost equal to the P, so you can approximate the value later when you draw an exam. So now you have the Q, which is very tall, and then you have the last P, which is we can say it's half of the third one because it's nearly 2,000 and the third one is already like 4,000, 5,000 like that, so just approximate it. And then we have the Q, which is going down, and make sure that the Q is supposed to be shorter than the first Q, the third Q I mean, because the third Q is already like 4,000 and this one is like only 2,000. So now you cut everything, you will get that tiny leftover Q we have there. So we connect from the last corner, which is always on the left, to the corner that is on the right side. In this case, it does not stop here because the P is everything, is the 4 parts that is plus together. So now you connect everything and you get the power triangle of everything that you need in this one. You can actually connect every kind of corner, every kind of side together, but it will look like more complicated. But it is the same because the question is to ask how to find the power triangle of the total circuit. Okay, that's it. Thank you and good luck. Bye bye.